All right, let's talk root canals. If you've ever heard those horror stories, I want you to just push them aside for a minute. Today, we are going deep, way down inside the tooth to see the incredible, high-tech, microscopic battle that actually saves it. So let's get into it.
First things first, we've got to bust a huge myth. Most of us probably picture the inside of a tooth's root as, a simple, straight tube. But the reality? It's way more like a microscopic maze, a super complex three-dimensional system of tiny branching tunnels you literally cannot see with the naked eye. The difference here is everything, and it's the core of the entire challenge we're talking about today.
So just how complex is this maze, really? Well, get this. In a lot of teeth, studies show that the traditional mechanical files, they can leave up to 80% of the surface area completely untouched. That's a massive amount of space for bacteria to just hang out and cause problems.
And as if that wasn't enough, as those files are working, they create this stuff called a smear layer. The best way to think of it is like a sticky sawdust, a paste made of tooth debris and bacteria that gets plastered all over the walls of the canal. This gunk is the perfect shield for bacteria, protecting them from our disinfectants and making the job that much harder.
So this brings us to our first deep dive. To really get what's going on, we have to appreciate the hidden, complex architecture of a tooth's inner labyrinth.
See, this labyrinth has all these crazy features that make it so tough to clean. You've got lateral canals shooting off to the side, little web-like connections called isthmuses, and these apical deltas, which are like a tiny river delta right at the tip of the root. On top of all that, you have millions of microscopic dentinal tubules. It's a system that a simple drill and file just physically cannot reach. No way. Okay, so if just scraping the walls isn't enough, how in the world do we clean this maze? Well, the answer is chemistry. We need a chemical arsenal. These amazing liquid agents are called irrigants, and they are truly the unsung heroes of a modern root canal. First up in our arsenal is sodium hypochlorite, or NaOCl. This is the heavy hitter, the powerhouse. Its superpower is that it's the only common irrigant we have that can actually dissolve organic tissue. And, most importantly, break down that protective fortress that bacteria build called a biofilm. But like any superhero, it has its weaknesses. It's pretty toxic if it gets outside the tooth, and it can't do a thing against the mineral or inorganic part of that sticky smear layer.
Next, we have chlorhexidine, or CHX. Think of this one as the persistent protector. It has this unique power called substantivity, which basically means it binds to the tooth surface and keeps fighting bacteria long after you've left the dentist's chair. It's also way less toxic, but here's the catch, and it is a big one. It cannot dissolve tissue, and if it mixes with sodium hypochlorite, it forms a toxic sludge. So the order you use these in and rinsing in between, it's absolutely critical.
And our final key player is EDTA. This is the mineral buster. It's what's known as a chelating agent. Its whole job is to specifically target and dissolve the inorganic mineral part of the smear layer. By taking out this mineral shield, it basically kicks open the doors to all those tiny tubules, letting our other disinfectants get in deeper. By itself, it's not a great bacteria killer, and just like CHX, you can't mix it directly with NaOCl.
Okay, so we have this powerful chemical dream team, right? Each one designed to tackle a different part of the problem. That should be enough, shouldn't it? Well, not quite. The next huge challenge is actually getting these chemicals to work where they're needed most.
And that brings us to this crucial concept of activation. See, just squirting these fluids into the tooth with a syringe, it's just not going to cut it. We have to make them move, force them into every single nook and cranny of that microscopic maze.
One of the biggest, sneakiest problems here is something called vapor lock. And it's pretty much what it sounds like. A tiny, stubborn air bubble gets trapped at the very tip of the root. This little bubble acts like a cork in a bottle, physically blocking our chemical arsenal from reaching the most critical, most infected area at the very end.
The best way to think about this is with a simple analogy. Just using a syringe to irrigate is like using a garden hose. Sure, you'll get the main path wet, but you're not getting into the tight corners. Activation, on the other hand, is like bringing in a power washer. It violently agitates the fluid, creating powerful currents and waves that scrub the walls and blast away debris, including those annoying vapor lock bubbles.
So, how do you power wash the inside of a tooth? This is where the technology gets really cool. Let's take a look at some of the high-tech systems that make this happen.
A very common method is ultrasonic activation. A tiny, super thin tip is placed inside the canal and it vibrates at an incredibly high frequency.
We're talking 25,000 to 40,000 times a second. This creates two really powerful effects. First is acoustic streaming, which is like a tiny, violent whirlpool. And the other is cavitation, where tiny bubbles form and then instantly collapse, creating little shock waves that literally scrub the canal walls clean.
And if you thought ultrasonics sounded futuristic, get a load of this. This quote here is describing laser-activated irrigation. Yeah, lasers. A specialized laser is fired into the irrigant, which instantly creates and collapses a vapor bubble, generating these powerful shock waves. The goal is to create turbulent photoacoustic agitation, which is a fancy way of saying it sends the cleaning fluids blasting in 3 dimensions throughout the entire system with incredible force.
But maybe the most revolutionary approach is something totally different. The gentle wave system doesn't even put a tool inside the canals. Instead, the device seals over the top of the tooth and sends waves of broad-spectrum sound energy, what they call multisonic energy, down into the tooth. This creates a powerful vortex of cleaning fluids that cleans out the entire maze from the outside in. It's a real game changer.
So from this crazy inner labyrinth to the chemical arsenal and all this high-tech activation, it becomes pretty clear that a modern root canal is really a search for microscopic perfection.
So what's the big takeaway here? The modern disinfection playbook really has 4 key rules. Number 1, mechanical cleaning with files is just not enough. Number 2, you absolutely need a combination of chemicals to handle both the organic and the inorganic junk. 3, you have to activate those chemicals to make them work. And finally, number 4, there's no single magic bullet. Success only comes from a smart, combined strategy.
And all this leaves us with a really fascinating question for the future. We're already seeing incredible research into antimicrobial nanoparticles, tiny particles of silver or other materials. So could a day come when we just inject a smart fluid of these self-disinfecting nanoparticles into the tooth, making this whole complex dance of chemicals and activation completely obsolete? It's something to think about. Thanks so much for joining me.